morning, students. Welcome to another session of our sim optimization course. In this session, we are going to see about nonlinear optimization. And in nonlinear, we have two types, as you can see in your material, chapter 9. This comes in chapter 9. Single variable optimization and multivariable optimization. As you all know, nonlinear means after making optimization, after formulating optimization, it won't be a linear equation. It will be non-linear. It have a mix of 1 power 1 to negative all sorts of equation. So here it is in page number 65 and 66, and let us solve one problem which is in 65 theory, and this problem is already solved in page number 66. Let us explain quickly. So nonlinear programming problem 1, page number 66. The problem is C is equals to 500 plus 0.9x plus 4500 over x. C is the cost. C is the cost function. C is the cost function. So if you can see your material, okay, what is the problem there? The total annual cost of operating a pump and motor C in a particular piece of equipment is a function of x. So the cost of operating a motor, the cost of operating motor. The size of the motor in HP is given by C is equals to 500 plus 0.9x plus 4500 over x. So what is the, we have to minimize the cost. What is the major function? Find the motor size that minimizes the total annual cost. Problem 1 in page number 66. Here is no minimizing. We are minimizing. So in our I already uploaded maximum minimization optimization. There you can see the principles. For any maximum and minimum, if you have a nonlinear equation, you have to derivative it. You have to do the first derivation and equal to 0. Here we have a cost function. X is the motor size, and dc over dx is equal to 0. So perform first derivative. What will happen here? 0.9x 500 will be 0 because there nothing is there, 0, and 0.9x will become 0.9. Here 4000 over x will become minus 4500 over x square. How it will become? Make x upwards to become x power minus 1. So derivation of x power minus 1 is minus 1 times x power minus 1 minus 1. So when x power minus 1 become x power minus 2, bring that down. So minus 4500 over x square equal to 0. So 4500, and if you solve this, you will get x is the motor size, right? Plus or minus 70.7. So motor x is the motor size. It never be negative, so always positive. Take the positive one. So x is equals to 70.7 HP. So you must take this much size of the motor so that your operating cost will be minimum. That's what it means. Okay, the optimum size of motor is 70.7 HP. So what is the minimum cost will become? Substitute here. This is the minimum cost. If you substitute the x in this objective function, and you will get the minimum cost. So now we find the minimum cost, but as I said before, we must know whether it is correct or not. We must check it. Okay, and you have the first derivative, right? And do it one more time. Okay, and if the second derivative is positive, then this will be the minimum, isn't it? Our maximum minimum, we have a condition, right? Do any equation first derivative and equal to 0, and if the second derivative is greater than 0, that will be the minimum. If the second derivative is less than 0, the one here what you find is the maximum. So here is, if you do perform the second derivative, which is second derivative, this is the first derivative, right? From there, so second derivative d square c over dx square equal to 9000 over x cube. So anyway, it's a positive. Since x is positive, so all value is positive. So objective is minimum. We find the minimum. So that's what it means. I hope you all understand. Let's solve another simple problem in problem 2, page number 70. I'm not making a problem here because I already uploaded in the last session. Okay, problem 2, page number 70 in your course material. So what is the problem? Here in the production unit of a phosphorus trichloride, the cost price per barrel produced is given by this equation. Cost. This is the cost function, right? C is equals to 50 plus 0.1 P plus 9000 over P. Okay, what is asking? What is the P here? P is the number of barrels per day they are producing. That so this is the cost to produce one barrel. This is the cost to produce one barrel. And what is the P here? Number of barrels they produce per day. Per day. What they are asking to calculate? They are also given selling price. Selling price is what? Selling price of PCl3 is 300 barrels per day. Okay, $300 per barrel. What is asking to determine production level of PCl3 giving minimum cost per barrel, the A, that is the A. Production cost minimum. What is the cost should be minimum cost. Okay, so what is the minimum? Whether maximum or minimum, same thing. Find out the first derivative and equal to 0. So let's see the first derivative of this one. It will become 0 and 0.1 minus same 9000 over P square. So what is the P? So P is equals to, because P square equal to 90,000, P will be plus or minus 300. The production cannot be negative, so should take positive. So P is the, you should produce 300. If you produce 300 barrels per day, then the cost will be minimum. The cost will be minimum. To check it is minimum, we should find the second derivative, right? The second derivative should be maximum 0. To check, find second derivative. It is d 18,000 over P cube. So since P is the positive, this all value is positive. So this is correct. Now let's go to the B, the production level of PCl3, which maximizes the profit per day. So we have to maximize the profit. What we have done before here, we minimize the production cost. All right. Here we have to maximize the profit. Here we have to maximize the profit. How to maximize the profit? Because they didn't give profit function, they give only the cost function in the profit, if you remember. So what is the profit? Profit is equals to what? Selling price minus cost. Selling price they already mentioned in the problem, if you see, $300 per barrel. So what is the production cost per barrel? This one. The production cost is this one, right? So selling price is 300 minus cost function is 50 plus this equation, just keep it here. Okay, just simplify this equation, you will get the profit per barrel. Profit per barrel. So what is the profit per barrel? 250 minus 0.1 P, the same equation. This is the equation, dollar per barrel. So what is the total profit for the whole production? You should multiply with production capacity per day. This is the per barrel only, right? We want to maximize the profit per day. So you have to multiply this. This is the profit per barrel. So you should multiply with the total production per day. So that is the, let P, profit times production per day. So this is the equation you will get. This is the equation you will get. So how you do that? Again, maximization. Maximization means you have to do the first derivative of this equation and equal to 0. So if you do that, 250 minus 0.2 P equal to 0. If you do this derivation, okay. So P is equals to how much? 1250 barrel per. If you produce this much, this many barrels per day, and you will maximize the profit. Okay, and you can check it. You can check this. To check this one, you have to do the second derivative. Second, d square p1 over dp square. What will become here? It will be 250 minus 0.2, right? So that will be the, this is our production per day. And the C is, what is C? The production level of PCl3 at 0 profit. What is 0 profit? Profit function is how much? Product selling price minus cost. We have already found here, right? This is the equation, right? This is the equation. At 0 profit means selling price and cost price should be 0. Should be same. So selling price minus cost price is 0, right? This equal to 0. If you simplify this equation, and you will land here. So this is the, if you, the production is this much. Okay, at 0 profit, either you produce this or this. Okay, but choose the not maximum production, go for the minimum production. So this is the answer. So I hope you all understand. If you have any doubt, just please post your questions in the Blackboard, in our discussion board. Okay, thank you.